Algorithm design is a cornerstone of computer science, providing the tools and strategies needed to solve complex computational problems efficiently. By understanding how to construct effective algorithms, we can tackle challenges in fields ranging from data analysis to artificial intelligence. Central to algorithm design are several key paradigms, such as divide and conquer, dynamic programming, and greedy methods. Each paradigm offers a unique approach to breaking down and solving problems. Mastering these techniques is essential for developing robust and optimized solutions in the digital world. Algorithm design paradigms provide structured approaches to solving computational problems. Brute force involves checking all possible solutions, such as searching for an item in a list by examining each element. Divide and conquer breaks problems into smaller subproblems, as seen in merge sort, which recursively sorts and merges arrays. Dynamic programming optimizes by storing solutions to overlapping subproblems, exemplified by the Fibonacci sequence calculation. Greedy algorithms make locally optimal choices at each step, like selecting coins for change in the fewest number of coins. Backtracking systematically explores possible solutions, retracing steps when a dead end is reached, as used in solving puzzles like Sudoku. The algorithm design process begins with a thorough understanding of the problem at hand. This involves carefully analyzing the input and output specifications to ensure that all requirements are clear. Next, it's important to consider any constraints and potential edge cases that could affect the solution's performance or correctness. Selecting suitable data structures, such as arrays, trees, graphs, or hash tables, plays a crucial role in optimizing efficiency and managing complexity. By systematically addressing these steps, developers can create robust algorithms tailored to the specific challenges of each problem.